In calculus, we usually measure angles in radians rather than degrees. So just to remind you of the connection between the two, if we consider a full revolution of a circle, so we take a line like this and we consider the angle there, and we consider a full revolution as this line moves all the way around back to there, that total revolution is equal to 360 degrees. Now in terms of radians, that's equal to 2 pi radians. This allows us simple formulas to convert back and forth between degrees and radians. For example, 1 degree is equal to 2 pi over 360, which is equal to pi over 180 radians. So that's one formula we can use to convert from degrees into radians. Alternatively, we can write 1 radian is equal to 360 over 2 pi, which of course is 180 over pi degrees. And so that's a formula that allows us to convert from radians to degrees. It's also worth reviewing what a radian actually represents geometrically. So let's consider a circle here, and I've drawn out a particular sector of that circle. Now what I want to do is come up with a geometric understanding of what a radian actually is. So let's suppose that this angle here, theta, is 1 radian. So theta equals 1 radian. What does that actually mean? Well, if this circle has radius r, then that distance there is r, and that distance there, of course, is also r. Now theta equals 1 radian is the angle such that this arc length here is also equal to r. So a radian is the angle theta such that for a circle of radius r, the arc length swept out in this sector is also equal to r. Now we can use this to see why a full revolution of a circle is equal to 2 pi radians. Recall that the circumference of a circle is equal to 2 pi r. So the circumference is equal to 2 pi times the radius of the circle. Now we can ask how many of these sectors where the arc length is equal to r can we fit into this circle of radius r. So I could draw another one like that, for example, maybe another one like that, another one like that, and another one like that. All of these sectors have an arc length that's equal to r. So that distance there is equal to r, that distance there is equal to r, that distance there is equal to r, and so on. And of course, by definition then, this angle here for each one of these sectors is equal to 1 radian. Now we ask ourselves the question, how many of these sectors can we pack into this circle? Well, we know the circumference of the circle is 2 pi r, and each one of these sectors is going to use up r, so we can pack in a total of 2 pi r divided by r, which equals 2 pi r sectors. That's how many sectors we can pack into this circle of radius r. And now because the angle within each one of these sectors is equal to 1 radian, that means there is a total of 2 pi radians as we go all the way around the circle once.